Hi, today we'll be seeing a very important topic in WPF, which is to create a custom control. If you are working on WPF application, there are situations where you might be forced to create a custom control based on the requirements which are there. Today we'll be creating a custom control from scratch. So please be there for the entire video so that you can get to know how to create a custom control. So the control that we are trying to create today is this the spinner control. As you can see, it's a spinner control with animation on, and it actually rotates forever. So we will see today how we can create this custom control from scratch. So for that, let's jump into our code. So before jumping, I would like to request everyone to please subscribe to this particular channel so that you will get notifications for the new videos that I'm posting. And if you like this particular video, do press on the like button. It will help the video a lot. Now come jumping into the code. Now I have created a solution which will have which has a WPF application. Therefore, we will be using that particular custom control in this particular WPF application. So I will create a new custom control project, WPF custom control library. So there is a template available in Visual Studio where you will be able to create a custom control library, which is called WPF custom control library in .NET Framework. I will choose this one and I will name this particular library as spinner control. We are creating a spinner control. Let's wait to get it created. Yeah, it got the project got added into this particular solution, and let's rename this particular guy as my spinner control. Yeah, like to reflect. As you can see, the this is the custom control class which is inheriting from this control library. So we will try to add some behaviors to this particular control by means of a dependency properties. So we'll be creating a few dependency properties which are required for this spinner control here. So dependency properties are nothing but, in simple terms, it is just attributes for that particular control which we'll be using in our custom application. In our case, we'll be adding certain attributes which are relevant to the spinner control. Some of the attributes are like this. We will add a dependency property called diameter. So this is a shorthand representation. If you do prop dp, it will expand into a dependency property. So we will add a diameter property here. We'll change this property name to diameter. And then the owner class we have to mention. The owner class is the my spinner control class, and the default value we need to specify, which I will give it as 50 as of now. The diameter we have defined. The next property that we are interested to define is the thickness of that particular spinner control. So we will define another dependency property using the prop dp shorthand, and we will do double tap and it will come, and then we will add thickness which is of double type thickness. Yes. So once it is added, we have to change the owner class to my spinner control, and the default I will give it as 5. The thickness would be 5. The next dependency property is to which determines whether that spinner control should be present or not, or that particular functionality or the spinner control should come up or not. So that dependency property I will name it as is loading. I will add a boolean property called which will which will actually control the visibility of the spinner control. I will mention the property name as is loading. And then on our class, the new good thing with Visual Studio 2022 is that it actually knows what you are trying to change. Since you have changed already in the previous uh, dependency property, it is suggesting that this is the change. We just need to do tab to accept this change. This is particularly good thing that I came across in previous 2022. And I will give the default value as false. And then the next thing that I need for this spinner control is the color of that spin control, so that I can change the color. The property would be of type brush, and I will name this property as stroke color. So yeah, we have done till this. We will define the default brush for this thing as black. We have defined these dependencies property. Since this is defined, we have to define our control template for the spinner control, or in essence, how that spinner control should look like, and we have to specify the animation, etc. For that, we can specify in this particular theme section there is a XAML available. For this XAML, will determine how your spinner will look. So here, we will be adding a few templates. One is a control template for the spinner control. We'll be adding. We will remove this border as of now, which is by default it came, and we will be adding, since the spinner control, as you can see, we can that is spinner control can be modified out of an ellipse or a circle. If you see this, if you analyze the spinner control, you will see that it is a circle where 75 or some portion of it is line and some portion is gap. So we have to modify this particular circle to represent like this, to be like this. So we will use an ellipse control for that. We can modify ellipse to behave as a circle by actually controlling or defining the width and height equal of that ellipse. Then it becomes a circle. So we have to make a circle now. We will define the width as, we will bind it to the diameter that we have defined in the uh, spinner control dependency property. So width will be diameter, and I will specify the relative source as the templated mode will be templated parent. That means that this particular diameter is defined in the templated parent, which is nothing but our own control. So here it will be able to find the diameter property. Similarly, we will add the height. So we are keeping the height and width the same since we want a circle. So we are modifying the ellipse to become a circle, and then we will go on and add the stroke for the ellipse. So we will define the stroke as stroke color that we have defined in the templated parent or the frequency property for the spinner control. We will add a relative source where it should look for that particular binding property. We'll specify the mode as templated parent. Then we will define the origin for this particular ellipse. We will specify the origin as zero point 0.5. The slight offset we will define. Not 0, so you can also specify a custom origin as well. For now, I am specifying zero point 0.5, zero point 0.5. And next is the defining the stroke thickness of the ellipse, or the how much thick that particular line, ellipse line, should be. That is defined by the stroke thickness, and we will have a binding for it also. That binding will bind to the thickness property that we have defined, the control template that we have seen before. Now we will specify the relative source, and the node will be templated parent again. And then next we'll set the visibility of this ellipse. As I said before, the visibility we are deciding based on the ease loading property that we have defined in the control template. And ease loading, we will use a converter for it. Since visibility, we have to convert from Boolean to visibility type. We will use a converter for it, and we will be adding a static resource which is already defined, predefined static resource we'll be adding. That is Boolean to visibility converter. So this converter we have to define as a resource for this control template. We will define the resources, control template, what resources we will define, and in this thing we will add boolean to visibility converter with that key that we have given here. we will specify the key here. That's it. So we have defined the converter as well. Also, we have to specify where to look at. We have to specify the relative source. We have to specify the relative source as mode completed parent. So this might seem a bit complex, but if you try to understand what we are trying to do, then it becomes pretty easy to understand what we are trying to do. If you just look at the XAML, the finished XAML for the first time, then it might look pretty complicated. But if you do step by step, then it becomes pretty easy to follow. We will define we have defined the template parent. Now we have defined the properties of the ellipse or set the properties of the ellipse. The next thing is to define the stroke dash image. The next our requirement. Now we have defined a complete ellipse. Therefore, we want to cut a portion of that ellipse. As you can see in the this particular spinner control, small portion of the ellipse needs to be cut so that we can get a feel that it is a spinning object. So small portion of the circumference needs to be cut. Therefore, that is defined. That can be achieved using defining a property inside that ellipse called ellipse dot stroke dash array. Therefore, here this will determine how your spinner control should look or how much portion of that circle or circumference needs to be cut. That is defined here in the stroke dash array. We will use a multi-binding for it since we have to convert into the stroke dash array type. So we have to use a multi-binding since we will be inputting two parameters to it. For this multi-binding, I have to use a converter. So the converter will be the circle param to stroke dash array. So we have used a multi-binding since we are dealing with two properties. One is will be the diameter and the thickness that will be defined inside it. And since we have to convert it to stroke dash array type, we will be using this particular converter. We will define this converter in short while. Let us complete this particular XAML first. Then we will define that binding here. Define the multi-binding correctly. Then we have to let's define. Otherwise, it will start complaining. It will not IntelliSense will not be available. Let's define the converters as well. Converters circle param to stroke dash array. This we can copy it. We have defined the converter. We will use the what all binding is be part of this multi binding. Some reason this thing, yeah, and we use a binding here. We'll get to it. Now we will define. So we have defined binding, binding path. We have to use the diameter. One property will be the diameter, and we will define the relative source as same mode will set as temperature parent. We have already defined. We will add one more property here, which is called thickness. So these are the two parameters which are passed to the stroke dash array. That's how we are defining this particular thing. So we will close this particular thing. So this is complete. We will end the multi-binding as well. Yes. Completed the multi-binding part so that after this particular step, we will get a clipped circle or the some portion of the circumference will be clipped. How much will be clipped that is defined that can be defined here in the circle parameter stroke dash array converter. So we will be adding a new folder for the converters. We have added and we will add a new class. So the class will be circle param to stroke dash. From the stroke dasher we will be adding here. We have defined and it will be I multi-value converter since we are dealing with multiple values. I have already defined that particular converter. Let me just copy paste that particular code here. It is nothing complex here. So what it does, it actually gets in the values which you are passed through that binding, and it checks the length is less than 2, then it does nothing. We have given two parameters, therefore this is kind of a gatekeeping check that this particular convert gets triggered for the right set of values. Then we will be calculating the circumference that is required, that is basic mathematics to pi r or pi d formula that we are using. And using the circumference, we are getting the line length and the gap length. Line length is the part of the circle which is visible. So I am setting only 75 percentage of that circle should be visible, and I am setting the rest of the thing as invisible. This is the line length and will be the gap length. If you see here, the 75 percentage of the circle is visible and 25 percentage is not visible. That is decided here. If you modify this particular value, if you set 50 percentage, then the spinner will look semicircle. So that is decided here, and we will be returning a double correction, and we will be returning the line length by thickness. We have to actually normalize it based on the thickness. So that is a that is how we have to return this particular value back as a double collection. So we have, since we have done it, yeah. The next big thing is to make this particular circle rotate. So therefore here comes the interesting part. How we can make that particular thing rotate? We have to animate it. So here we will be able to animate using transformations. So here I will set a default value for the render transform, and that render transform, in that render transform I will be using a rotate transform, and I will use the property, the transformation property rotation. I'll name it as rotation, and I will set the initial angle as 0. So I will be using this particular property. So that's why I have defined inside the render transform. So I'll be using a rotate transform, and I'll set the initial angle as 0. So you will try to play with this particular angle. You will try to change this particular angle multiple times so that you will make that particular circle to animate, to look like it is rotating or look like it is spinning. To make it spinning, we have to actually work around this angle property of that rotate transform. That's why I have defined inside the render transform. And then how to make it rotate, how to instruct that the how to make that particular control to rotate, that we will define. That's a storyboard. We will define a storyboard for it. We will define a trigger. So when that particular transformation should happen, that is defined inside the trigger. So it should happen on event called loaded. So whenever the control is loaded, it should do the following actions. What actions we have to do? We have to do an animation. So we will begin the storyboard. We will define a storyboard. Storyboard will list a set of actions that are done on a particular property, on a particular visible property of a control, so that to make it animate. So here we will define a single storyboard, and we will define the repeat behavior of that particular storyboard as 4 hours, so that we can see that the spinner is continuously rotating. We will define this repeat behavior as 4 hours, and we will define a double animation. Means it works on a double property called angle. That's why we have defined a double animation. We'll define a double animation, and we'll set the double animation properties based on the storyboard. Storyboard dot. We will define a target name and target property. Target name we have already defined as rotation, already defined in the render transform, and then we have to give the target property, on which property you want to play around with, so that you can make that particular control animate. So you want to play around the angle property. So from which range to what range you want to play around with the angle property that is defined. You see that from you have to play around from 0 to 360 degree, the entire circle. So that's it. Once you have defined an animation, you have done with the basic setup of this particular control. You have to define a namespace for this pillar converter also here. So I will define the namespace as CV, pillar control converters. Once it is defined, we are good to go. We have defined that animation part on which property it should animate, and this particular section defines the uh, flipped circle, or how much that particular circle needs to be flipped. That is defined by this section, and this is a basic ellipse control that we are trying to modify. So that's it for this particular spinner control. So you are mostly done creating a custom control. Now it's time for you to use that particular control in your WPF application. So in this WPF application, I'll just add a project reference here for the to the spinner control just for demo purpose, and I'll be using the spinner control. I see that I have to add a namespace to it. Let me see if I define the thing as spinner control only. It is my spinner control. So you have to define the my spinner control, and the IntelliSense will prompt you to add the namespace for it. Then once you have defined the my spinner control, you need to define the properties, the dependency properties that you have defined in the this particular custom control. So you have to set those dependency properties here in your application. For these properties will be set back to the ellipse that you have defined in the control template. So here I am defining the diameter as 100, and is loading will be true always, should be visible all the time. Stroke color will be just for the demo process, setting it as caret blue, and the thickness I will be setting it as 5. I guess we are done. Let's try to build this guy up. There are a few errors here. Oh, I have used CV instead of CMP. CV is the converter namespace name. What are the other errors? My spin control. Okay. There is an error in the pillar custom library. That is why I didn't build it. So let's try to build it again. Yeah, it got built successfully. Build is successful. And let's see now whether our spinner control could not be displayed. View details. Binding cannot be set on converter property of the multi-binding. So a binding set cannot be set on the converter property of the multi-binding. Let us see what is going wrong there. In this particular guy, the stroke dash array is pointing from here. Binding cannot be. Oh, this is not a binding. This is a static resource. So it's my fault. It's not a binding. And we will try to rebuild it. Then we'll go to main.saml. Yeah, our spinner is good to go. It is coming here. So we'll just start that application to see whether it is loading. Yes, this is coming. So this is how you can create a custom control and use it in your WPF application. If you have any doubt, please let me know in the comment section below. And please don't forget to like this particular video if it found helpful, and to share this video with your colleagues and friends. Thank you for watching. See you in the next video.